But when we say move forward, we immediately don't give feedback. We want to make sure that he crosses his original boundary, right? Which is his natural. Like at least he reached there by his own. Because if you give feedback, he may be disturbed. Now, when he reaches there, he knows where he has reached. Why? Because of the vibrotactile feedback, right? So now he moves a little bit more, right? Till he feels. So what happened? Initially they fall also. So we have like kind of this rope where they actually not fall. Or we ask them during the training. We ask them, if you feel like falling, take another step. Don't actually fall, right? So this feedback, when he is almost going to there, no feedback, no feedback. Once he crosses his own original limit, because now he knows he will fall because his brain is trained for that. So we immediately give a feedback. No, you are not falling. Move little forward, right? So what we observed is, and similarly for the backward. So what we observed is, when this kind of feedback is actually given, you can see there is significant difference between the improvement in the LOS in this particular condition. COP. You can see this particular area. There is significant improvement from the previous case compared to this. But the problem here is, if you see these results, they are very interesting. What we actually observed is, which is very interesting, and nobody actually knows why it happened, and then we conducted a third study also. This feedback actually really helped, but unfortunately, it did not help in the prosthetic side. You got my point? You got what I'm trying to say? When originally he was doing like this without feedback, which was his maximum limit of stability. When we gave feedback and the training, what happened is he could actually, so we are giving on the both leg, he could actually move his sound limb little more forward, but not the prosthetic side. So that's why you see here, this is COPS. S is for sound limb. Sorry, I forgot to tell you the acronym. S is for sound limb. COP is P means prosthetic side of the COP, and COP net. So COP net will come somewhere in between. So you see, this COP net was bit improved, but that was not because he could improve on the sound prosthetic side. He actually improved on the sound limb, right? So we are again confused. Like, although it is improvement, but that is not what we expected. So what to do now? So there are two cases. You got the point? So if this is a research paper, like Mike is doing general for like 2 days, what would you expect? What would be a new plan to study? Because we published this in a very good journal, but then we also thought, and reviewer also asked, what is the reason? Like, why did not he improve on his sound prosthetic limb? Although the COP net improved, which is very good, but we are surprised that he improved only on the sound limb, but not on the prosthetic limb. So how will you plan a new study then? Question is clear? Okay. Because this was one of the very first study in this area, we got published. But otherwise, if it would have been done after 5 years from now, they would reject it. They would say there is improvement, but how? That does not make sense. Why? Because just imagine, it is kind of this situation. Although this was not this situation, but just assume I'm not moving this leg, but this leg I am almost moving like this. Although they are not doing like this. Are you getting this point? This is fixed, right? This I can move anywhere because it's my sound limb. So overall will increase, right? But that's not the correct way to saying that you have improved. Yeah, so yeah, of course, that is a very interesting study. If you really want to prove it, have both leg amputees and then see what happens. Actually, this is a very good idea. I will ask my student to do that. That's what when you discuss more, you get a lot of ideas. We did not thought of that way. So we'll acknowledge you, definitely. So that's a very good point. So how to prove that now? What happened? Why did not he improve on the prosthetic side? But he did not do like this, what I'm saying. I'm just giving you an example. He actually did like this, the original protocol. But we found that actually he is more improving on the sound limb rather than on the prosthetic limb. With this, we actually concluded that, okay, there may be only two reasons. The one reason may be that because this vibrotactile, he is not able to either understand or whatever, but this is not effective. That is one hypothesis one. Second hypothesis may be he has a fixed ankle joint, and maybe that's why he is actually able to translate those new feedback into the brain, making a strategy to move ahead. But this fixed ankle is not able to provide that much of flexibility. So we thought, okay, let's plan this. So let's have both foot, fixed ankle and movable ankle, and then see whether our hypothesis was correct or not. That is the only way to go ahead. Of course, that is also a very good way what he is trying to say. So we planned a next study like this. So what we said is the conclusion of this study was amplitude significantly improves the LOS with vibrotactile feedback during weight shifting exercise. So this is just the analysis of different. You remember there were different segments in the sustain phase, P1, P. So it is just the comparison of them. These are the P values comparing this and all. Yeah. So this is the conclusion that phase 1 and phase 2 are significantly different in the intact lag, but does not show in the prosthetic lag. So in the sound limb, there was significant improvement with the feedback, but not in the prosthetic limb. Right. So it shows that the prosthetic leg COP does not follow the path of weight shifting exercise. Means he is not at all following the weight. So weight shifting exercise pattern is something like this. What is the weight shifting pattern exercise? The pattern is this. This is the pattern. You will have a solid line, DC line kind of thing. Then it will go up, then it will go, and then it will go down. So this is the pattern, right? I am standing, go forward, stay there, down, yes. But what we found is even this prosthetic leg is not able to follow that pattern. So we hypothesized that maybe this is because of only two reasons. The one reason could be like he's not able to actually understand, or maybe that's not effective. Either the training needs to be improved, or he needs more training time to actually get that confidence to understand it, or maybe he can quickly understand because he improved on the sound limb. So that was good news for us. So we thought maybe sound limb has actually the real pattern, like he has the actual ankle joint, and that's why he is not able to do it here because this is a fixed ankle joint. So let's try to do this way. Let's have a movable ankle joint. Let's have a fixed ankle joint and see whether actually our hypothesis is correct. So we wanted to go a little deeper then, right? And this is how your research should go. Don't discourage by your negative results. See what could be the possible reason. Finding a new reason is a new paper, right? So anyway, this is kind of a different story. So this was the conclusion. Yes, this is the paper. Yeah. So what we found is that given a vibrotactile feedback during weight shifting, only sound side LOS improved. Only on the correct leg the improvement was there. So therefore, this is what we concluded. It is unclear that unimproved LOS in the prosthetic size is due to the mechanical limitation of the prosthetic, that is fixed ankle joint, or vibrotactile feedback does not affect the amputation size. So I told you, right, everybody of you. If you ask me some question and I say, I don't know, I have to do experiment. That is the research. So if you ask me this question at this stage, like 1 year back, I would have said, I don't know, I have to do the research. Right? So this is what we wanted to see. What is the outcome? What is the point? So then we took this kind of prosthetics. So this is few prosthetics foot available which provides the ankle motion, but it provides ankle motion only in the one joint, which is our hypothesis. So it suits to our hypothesis very well. And this is and this is kind of like fixed ankle joint. It does not move, but it has a little bit of push in this so that you can little bit move forward. Yeah. So to answer of a research question by comparing the LOS of transformer amputee with sash foot, which is a fixed, and the single axis prosthetic foot while they perform the weight shifting exercise. Everything clear so far? Good. Okay. Again, everything is same. No change in protocol, no change in statistical analysis, nothing. Only thing is now that he will have to wear it on both the time. Right. So today he comes with this, tomorrow he comes with this. Okay. And the same training time, everything will remain same for both of them. So I'll directly go to the results because protocols, everything is same. Signal processing part, filtering, everything is same. Okay. So now what we did was, so they have to move forward as well as they have to move forward. So this is again the same kind of curve we saw earlier. And this time what we also did was, actually, if you remember in the last, so this is basically, we actually divided more phases because we wanted to see more deeper into the waveform. Like I told you, earlier we were talking of this sustained phase as a single phase. So if I want more time resolution, I will do analysis window by window. Same thing we did here. So we made a lot of windows, almost 8 windows for this sustained phase. T1 is the transition phase from standing to moving forward. Similarly, this transition 2 and then R1 and R2 are the resting, right? Or rehabilitation, whatever you say. P1 and P2 are the baselines. You got the point? Entire COP time series, how we divide it. Baseline is divided into 2, transition is 1 point only. S1 to S is a sustained phase, he has to sustain that LOS for a time. T2 is basically the transition time back to the original position, and R1, R2 is the rehabilitation. Like whenever they come back, they need some time to relax, right? Yeah. So this is kind of very interesting. So you can see that degree of freedoms 2, why 2? Weight shifting exercise, only 2 degree of freedom. Yeah, you know all degree of freedom, right, for a statistical analysis. So either move forward or backward, right? Vibrotactile feedback, and then this T is for phases. If you remember, they are the phases, and then based on that, what your is analysis. These are the all statistical values. So this was the 3-way ANOVA statistical analysis for weight shifting, vibrotactile, and division. You got the point. So I have 3 parameters, 3 variables. What are the 3 variables? Weight shifting exercise, whether it is forward or backward. Vibrotactile feedback, whether it is vibrotactile feedback or not vibrotactile feedback, or the divisions. Divisions means where I am in the time, which place I am localized in the time, whether it is baseline, whether it is transition, whether it is this kind of. Okay, so single axis would follow the WSE pattern. Single axis pattern means which can actually allow him to move little bit. So that actually, so our hypothesis previous was that actually we don't know whether vibrotactile was so this feedback is not good enough for him to train in that way. But it was not the vibrotactile feedback. He was able to actually strategize his motions by using that artificial COP, but actually this ankle motion was not allowing him to actually actuate by that knowledge. So what we found is there was something very interesting, and significant effect of vibrotactile feedback is shown with single axis foot. So if you see here, these are the divisions of all the phases, and you can see the effect of feedback on both the. So this is Sach foot, which is having the single no movement. This is one with the single axis feedback, and this is the limit of stability for prosthetic side. You can see it has been improved, and then you can see all the 4 bars for this. So V is basically feedback for Sach foot. So Sach foot means no movement in this direction. This is no feedback, the black one, for this single axis foot, and then similarly for Sach foot. So feedback for single axis foot, no feedback for single axis foot. Feedback for Sach foot, no feedback for Sach foot. Right? So the interesting part is, let me come up to the final story. Solid ankle has a greater LOS, and vibrotactile feedback improves the LOS with movable ankle joint. This is kind of totally mess. Results are totally mess. Do you know why it is mess? But after this mess, my collaborator from IIT Gandhinagar and my PhD student, you won't believe we have 2 hours of Skype discussion. Almost my battery was gone. And we were like, what is this happening? What to convey to the reviewer? And we submitted in IEEE haptics, and we got very good feedback. Because our hypothesis was very interesting, although the results are not in our favor. But we conclude something very interesting. So first, did you get the outcome of this study? Then we'll discuss the discussion part. What is happening is, when there is a solid ankle joint, the person's LOS is much better than the ankle joint with the joint which has movable joint from the figure. But the vibrotactile feedback does not improve in the single axis, in the fixed ankle joint, but improves in the movable ankle joint. And now you have to convince it to the reviewer. And with the English my student have, just imagine what would be the manuscript. So you have to convince reviewer that no joint ankle is better than the single axis joint for LOS, but it does not improve with the vibrotactile feedback. This one, which has a movable, is lower than this, but it improves with vibrotactile feedback. So just imagine what to tell to the reviewer, and that too in IEEE transition, where most of the people are engineers. So what we concluded is, in fact, it came from my students. I was very happy. At least he gave a very solid reason. He said, based on some literature, he said, more the functionality increases, the stability actually decreases. So we found it in the literature. I'll show you some papers there, which says that more the functionality increases in a prosthetic limb, the amputee feels more conscious about the stability, right? And what he concluded, if you see the advantage of this movable ankle joint, just forget about the vibrotactile feedback now. There is a fixed ankle joint, there is a movable ankle joint. So movable ankle joint are preferred because, can anybody tell? Because they will give you the normal kinematics, because you can move your ankle, right? Sach foot will not give you any movable the ankle joint, right? So that way, this is good, and it also improves with the feedback. But point is, even though this Sach foot, which is a non-movable joint, is not improve with vibrotactile feedback, not gives the gait kinematics properly symmetry, but it improves. It has, even without feedback, it has better LOS than this. Right? So we actually convince the reviewer that it's kind of like, if you want to improve your limit of stability, if you want to really improve your stability, then of course you go with Sag foot. But if you want both, if you want to improve on your LOS as well as you want like kinematic symmetry while walking, then this single axis foot is better, even though it may not provide as much as good balance compared to the Sag foot. Did you get the point? Is the story clear? Is it convincing enough to be published? So although very messy results, but if you see as an overview, you can always make a good story, but convincing story. Because we could have dishonestly say, no, it also improved. But to be very honest, it did not improve in the Sag foot. But what we observed very interestingly, Sag foot LOS without feedback is actually better than this vibrotactile with the feedback in the single axis. This is solid axis, but it has originally so good LOS, which is much better than this single axis with the feedback. But the problem is it has no effect on the. So, but at least we could answer our hypothesis. That is the best part. So maybe that's why reviewer were confused, because we were not very sure that it did not improve in the Sag foot because it was not effective. But this is not the case. If the functionality is there in the ankle joint, this vibrotactile is effective. So we were very clear about hypothesis, and the reviewers were also very nice about that. They accepted, but they were also like, so what should we do? What should we recommend? Whether you should Sag foot or whether it should be there. So then we came with the conclusion that of course everybody prefers generally in the amputee population the kinematic symmetry. And the reason for that, they don't want people to notice you that you have some problem with your leg. But then we said, if you are using that, use the vibrotactile. That's the message. You got the point? So very clear. We agree that Sag foot is much better, but because you prefer the single axis foot to be socially acceptable or socially not notified that you have some problem, so you use that foot, but use it with the vibrotactile foot, so that you also improve on balance as well as on your kinematic symmetry. So the research should go like this, very clear. You should be able to convey what you did, why you did, and what happened. And whatever happened, can you make a story out of that, which looks like a scientific story and very convincing also. Right? So I think that's all I have. I think I don't have. So yeah, so these are the just futuriscope. We published a lot of this. So it's a bit back. So we also got this award from a company in Japan, and they gave 2 people round fair trip, and they also asked that we can get you in touch with some Japanese company who can buy your system for improving the balance and all. So this is a very leave a nest company which is from Japan originally. Every year they across the globe they will create they will run a competition kind of thing. So my student participated. They did not ask me. They both went to Japan, even though it was for supervisor and the student. But they both went. They came back, showed me pictures, and we won this award. So it was very interesting to me to see that the students are doing very well. And then we also got some open house, which is very prestigious program at IIT Delhi, where the alumni creates fund and give to the best science going on in the IITs. And yeah, so that's all from my side. So if you have any questions, feel free to ask. Yeah. Yeah.
So is there no way that like in the amputee population, they do not have this skill, so that actually work?
No, that's what I was saying. So when Mike and I were in IIT Delhi, I showed Mike a very interesting article. So there is a big company which makes this prosthetic. They did it almost 2 weeks back, and they published in Nature. So they did exactly what you are saying. Like, we are giving the feedback on the surface. They are giving directly on the nerve, because that is a natural pathway it should go. Then brain does not need to learn it, because brain is trained to learn that. It is just the amputation that happens. So they give exactly the same information. They implant a chip on inside the body, and then when it goes there, they don't need to learn, because they are just putting it like inside, exactly on the muscle where it was supposed to go, or the nerve, and then they give artificial charge there, the current, and then it goes to the brain, and they feel like they are having the natural leg, but then at the cost of being non-invasive. Sorry, being invasive. Ours is kind of non-invasive. That's why it needs more time, because this surface is not trained to take that to the brain in natural way. So he needs some training to train the brain because it is a new learning for the brain. But in their case, it is a natural learning. The same nerve is going to the brain. You don't have to train the brain. Brain is well learned from his childhood. But again, it is very, very invasive. Yeah.
Sir, in the single axis foot that you had used, was the joint at the axis, was it freely moving or was it just
No, there is an anti-lock kind of system also. Okay, it's for safety purpose, but
I'm not asking for the lock, but is there how will that motion be transferred? Because if it is a freely moving joint, so there shouldn't be shifting of LOS.
No, because they are using it for so this kind of single axis processor foot is very popular. So I don't know exactly what was the mechanical assembly and how did it happen, but what I came to know that this single axis foot is very popular because it actually allows to do this kind of movement, and that's why it gives the ankle angle also. So it's a bit of dorsiflexion and plantar flexion, which creates the gait symmetry while walking. Yep. Yeah. So Mike.
So Deepak, I'm curious what the limit of stability measure when you were talking about how to resolve your answer of the Satch foot has a greater limit of stability. Sometimes we've talked about prosthetic feet are like standing in overly rigid boots. We don't really have an ankle, but you can lean into the boot very far. So I don't know how many skiing opportunities there are in India, but if you have a chance to mount your foot onto a ski, it has a long length in front of it and behind, you can lean to the point where you would naturally fall over, but you can't because your limit of stability now is 3 feet ahead of you on the ski tip.
Yeah.
So sometimes just having a plank underneath your foot allows you to really utilize the limit of stability. But then we would argue that you have a high stable system, but a very immobile system. Right?
Yeah.
So where the single axis foot has more mobility, but naturally then less stability.
Yeah. I was not aware of that actually. My student only came up with this logic, and can you show me some evidence, some literature, and it was there. So that was the time when I realized, oh, we are safe. We have some justification that why did it all happen. Yeah, but that's a very important point. Yeah. No questions?
Sir, the center of pressure profile for both the legs in the case of Satch and solid single axis is that will be tuned to be the same in both the legs.
So what we observed is that when he was wearing Satch foot, the prosthetic side COP was not improving a lot. It was and in the sounding, it was really improved. But in the Satch foot, even if it was not improved with the vibrotactile feedback, but without vibrotactile feedback, COP in the Satch foot was even better than the single axis foot. That's what we observed. That's why we investigated whether it is because of the mechanical constraint of the foot, or whether it is because he could not perceive it, or it was not good enough for him to use it as a control strategy for moving when weight setting exercise.
So will the energetic spot of this foot is more? Is it efficient or it is not efficient?
We discussed it in the discussion section a little bit because we did not explicitly run this experiment for this, what you are saying. But we have discussed a little bit. Maybe I can share that publication with you and you can just go through it. Okay.
Different examples, right? So the sham and the definition of the sham, whether it is a match or it is a
Yeah, I agree. We have not. So that's what I said. There are many reasons that why he could not improve there. Maybe like you said, his thigh health is not good. But yeah, that would be one of the reasons, of course. But based on our constraints, we only focused whether it is due to the mechanical constraint of this, or whether it is due to that vibrotactile was not effective on that particular side. But yeah, it would have been great if we also measure some kind of health of the thigh and say no, it could be because of this region also. But yeah, that's important. That's very important. Okay. Okay. So let's go for lunch because Dr. Periyaswamy is not here, so I can have the privilege of announcing for lunch. Oh yeah. Okay, so yeah, so sorry. So actually, Dr. Periyaswamy is not here. So he actually. Hello. Yeah. So I think where he went, I don't know. But he's given me a responsibility which is very, very important for me to do. So what I want is because, as you know, Mike is leaving to the airport just in 1 hour, and as the GIAN program concludes, this is a mandatory that feedback is there, has to be there. So ideally, we will have it in the evening, which is when the officials from the university will be here. But because Mike won't be here, so we want to, oh, he's here. Do you want me to carry on or you want to take it? Are you sure? I don't know. Okay, so I would request that at least the feedback should come from a general population. It should not be like which is happening in the question that only questions are coming from this side, no question from this side. So at least feedback should come from everybody. At least, so maybe you can 6 to 7 people around. So ideally, you should volunteer for yourself to give the feedback, and yeah, anybody of you, and so we'll listen to you. And we will have this exercise in the evening also whenever we are doing the validatory. But we are doing it for Mike because he will not be there that time. So we want to listen to your feedback. So can who wants to volunteer? Or maybe you can, yeah, I think ideally if you can come here and say that is good. So this is not a question. This is we are asking for one. We have to take picture also. I mean, it's mandatory. Yeah. So do you want me to pick somebody? So I request you please at least, yeah. So ma'am is always wonderful. But please come this side so that, no, we have mic. So I think that is great if you can come here. And I request that after madam, please volunteer to give the feedback. It's very important.
So I would like to first of all thank you, Dr. Mike, for coming across the globe to take the course. The first feedback is it's a very short time. So within 5 days, we had a nice time actually, but we like to have more. It should be at least for 10 days like that. So the course is like you have covered the research areas. You shared your thoughts on the research and everything. So I am basically from electronics background. So I don't know much about biomechanics. So it will be helpful a little bit of basics were taken where we will get the idea of biomechanics. Then we'll get about the research area. So that's my feedback on this. Thank you.
Good afternoon, everyone present here. I'm Palani Dhanaraj from St. Joseph College of Engineering. I'm really happy to participate in this program. I got an opportunity to meet eminent people in this particular field and budding students. And really thankful to our foreign expert, Dr. Michael Sir, for giving various insights into the mechanics of legs. Actually, I'm into the main of the analysis of brain and brain signals. So this has become a big platform for me to understand the various terminologies and knowledge about biomechanics of lead. Thank you. Thank you for it.
Good afternoon, and all. Thank you, sir. Thanks a lot for your time. We are really grateful to have you over here. And regarding the feedback as such, I don't think so. I'm at that level to give a feedback, but the course has been really great for me. particularly because I've been from biomechanics background and I know I actually have been knowing the terminologies as such to understand what the things you are trying to teach. But the little thing that I found was, since the title had biomechanics into it, so the slides of the presentation are particularly for the foot biomechanics and not for the upper limb. So yeah, so, like quite a few there, but it's not like it was done that way. It was really very helpful for me, particularly for my project, and it helped a lot. Thank you.
Good afternoon. To be very frank, there are not many sessions where I enjoy. I mean, out of my first time I'm visiting here, and to be very frank, I didn't sleep in any of the sessions. So it was quite interesting. That's what I meant, and I'm really motivated. I'm thinking to go back and try something. So thank you for motivation. No bad critics. I really love the session. Thank you.
Good afternoon, all. I would primarily want to thank Priyasamy sir, Deepak sir, to organize this. This has been a very great platform where could we associate with people from different backgrounds and hence maintain the interdisciplinary nature. And I would, of course, like to thank Mike sir to take all the pain coming all the way from US. And the best thing that I like is the introduction of journal discussion. This is actually a very novel approach. Which most of us haven't experienced it before. So that is the only thing that I would like to concentrate. Thank you.
Hello, sir. My name is Sabari Vasan. I am a mechanical engineering undergrad student. Basically, I have interest in underactuated robotics, and I just want to learn about the dynamics of prosthetic legs and all to make robots more human-like. I am working in that platform. Yeah, I like the way the professors answered the questions, doubts, and yeah, intuitive thinking. We have he cleared the doubts very helpfully for us. Some of the lectures are thought provoking and stimulated our mind to work on beyond things what is in the previous literature. And I thank Professor Joshi sir for making us understanding these mathematics, because I am basically from mechanical background. I have the parameters like temperatures, angle theta, kind of thing, but the time constraint and this the electrical part of signal processing sir taken well. And yeah, I thank both of the professors for making the lectures more fun and interesting. Thank you.
I think I, behalf of department, I institute as well as my department, I thank Mike sir, because all the way he came like to give a wonderful lectures, like whatever he's had the knowledge like to motivate you. And I spent like in the this 5 days I also motivated just to do some research on biomechanics. Then only the collaboration will start, because I'm mostly my PhD work is related to only biomechanics, but I stopped there. I move on to device development, not working on biomechanics. Now, after hearing these kind of motivation lectures, then I want to move into to continue the path where I stopped. I really thank Mike sir because the first time I'm hosting a foreign expert in this institute. Otherwise, I have conducted so many workshops like when I'm there in Iran. There I conducted so many workshops, not foreign experts. There is no foreign expert. Because when the foreign expert will come means you have to handle like this. You should give good hospitalities. I don't know how much Mike has enjoyed the hospitalities and all. I think he really enjoyed last 1 week, and I'm sure the collaboration will keep continuing. Thank you, Mike sir.
So, because Mike is first time here in India and has been here for like 5 to 6 days, so we would be very happy and honored to hear from him about his experience and whatever. I know he has a lot of complaints about many things, but he's so nice that he did not say a single word. So yeah, he's wonderful professor. Generally, like I have been hosting some professors from US as well as UK, and I was sharing with him that how much pain I had at IIT Delhi when somebody from UK came. He made my life hell for 5-6 days. So, but Mike is so nice. When I was there also that time, as well as during last 5-6 days. So let us hear from him what he wants to say for us.
I didn't realize this was going to be part of the schedule, so I don't have anything prepared at all. But yeah, I've traveled a fair amount the last several years into different countries, several Asian countries recently, Japan, South Korea, Taiwan, and then South America and Central American countries as well. And I'm always really curious about the culture and about the history and about the people. And this is the first time in India, so for me, it was trying to compare what was in my memory about what I've seen in movies, right? Maybe it's the same for you. If you come to the US, you think it's Hollywood, and you think we're all of a certain wealth or a certain dress or something. And so I was doing the same, to come here and say, I've seen something that looks familiar, like the dirt looks this color, the trees look like that, and the sky looks like this. Okay, that's enough. But I also expected spicy food, and that you delivered on that from my perspective. I've been told there's spicier food in India, but it was enough for me, maybe even more than I need. But I really appreciate the people because you're also receptive to a foreigner, and that's not always the case. Even in the countries I've visited, sometimes there's a wall between the local people and the visitor. And even though they're polite and they're gracious, there's still like a wall between the face. I felt like here that wasn't the case. So I really appreciate that about, I don't know, if maybe it's just academics in India that this is the case, but that really means a lot, I think, to me, and I am happy to go back home and tell friends and family that that's the case here, and that they would be welcome. So thank you very much for that. I need to talk about coffee. So academics from the US drink a lot of coffee, and we drink really strong coffee, and usually without any milk or sugar. So I had to adjust to that a little bit, which is probably good because maybe I drink too strong a coffee when I'm back home in the US. So here, maybe I've been more healthy than back home. Let's see. It's been great to tour the labs as well, to see the facilities. Like the Siemens facility was very impressive. And so to come, with an expectation of what a university looks like and what an institution's capacities are, there's some general assumptions about every university should have X, Y, and Z. And this institution seems to have X, Y, and Z. The design of the buildings are different, and the temperature is different in various spaces that I am used to, because it rains in Eugene a lot and it's generally cold. And here I've been sweating the whole time. But it's great to see the facilities that are so well designed and so well laid out, and especially even this morning, the labs where the instruction occurs for the undergraduates, everything makes sense. It all is as you would want it to be as a teacher. And so it's just been fun to see that and realize what's similar and also what's really, really different from where I come from. So anyway, thank you very much for the opportunity. I really value the time, and I think definitely I will be back. So thank you very much.